Hello all, I am Bill, part of group number 2 for UMKC's Computer Science 5542, Big Data Analytics and Applications for the fall semester 2020. I'll be getting us started with providing an overview of our group project. We have chosen to do our project on the analysis of images to predict age, gender, and ethnicity. This sort of technology can help businesses to determine the demographics of their clientele such that they can better serve their clients and to optimize their marketing efforts. We utilized artificial neural networks, convolution neural networks in particular, to create models to analyze the images to be able to predict the stated factors that we wanted. Our goal was to create a single model to determine all three of the categories at the same time: age, gender, and ethnicity. We also investigated the ability to determine the mood of a person based on the image. The method in which we approached the problem was to come up with several solutions, test them out, and see which performed the best. We came up with three possibilities. Two were a combined model approach, and the third was a combined parameter approach. The combined model approaches both worked well, whereas the combined parameter approach did not work as well. We chose to go with the two combined model approaches. I will go over the data that we use for training and testing our solutions, and when I'm finished, Vasim and Debsankar will go over the two models that were built. So the data consisted of approximately 24,000 images, and they had three categories associated with them: age, gender, and ethnicity. The size of the images were 48 by 48 pixels. And here are a couple of distribution graphs of how that data was distributed across the different categories. As you can see, the data is not normally distributed across those factors. Here is our other model, and as you can see, another representation of the distribution of the data. I will now turn it over to Vasim, and he will go over one of the models that was created. Thank you very much. Vasim.
Hi, this is Debsankar, and I'm going to walk you through the model for age, gender, and ethnicity prediction from the Kaggle challenge. We have used UTK Faces databases, and of course, in the Kaggle challenge, they have simplified the dataset. Now, we have added one additional bonus feature to our project, that is identification of the mood or expression for different images. Without wasting any more time, I'm going to show you some code. Like in the beginning, I have mounted the Google Drive and started to explore the data in the pandas uh, data frame. And then I plotted some distributions like ethnicity distributions, which I can show you that there is a bias in a certain category of ethnicity. The gender is more or less evened out. For the age, however, there is a more population in 20 to 29 years of old uh, people in the image data set. So let's move on to how did we identify the mood. For the mood identification, we have used OpenCV library, which is efficient to detect the faces. And then we have used Hercascade model. What Hercascade does is that it is a pre-trained model. What it does is that it compares the pixels. It goes pixel by pixel and compare the the facial layout, the pixel layout at different regions of the face with the model configuration, preloaded configuration loaded in the saved model. So in our case, we have chosen to extract the smiley faces, that is the happy mood only. So you can see here that here I have loaded the Hercascade classifiers, and then here in the next line I applied those classifiers to the images, and then that way I identify if there is an image that matches the smiley uh, faces category. And you can see that in that way we have identified multiple images with smiley faces. So those images are identified. I mean, these are some random images, but we can extend these analysis to the entire data set to find out exactly what each of the faces mean. Um, I mean, it's smiley or sad, smiley or neutral. So these faces are smiley faces. Those are detected by our OpenCV framework. Now, moving further to the CNN model of for the uh, age, ethnicity, and gender prediction, we have splitted our data set into 70-30 proportion, and then for training and testing, and then we have the data generator designed in a class, Python class, which has different methods. Like a method takes care of splitting the data into 70-30 proportion, and then another is to generate the images in the NumPy arrays. And then we go to the model. It's a CNN model. The default, I mean, this model is based on, uh, I mean, layered architecture. We have three different branches in this model. This is a multi-output model. So we have three different branches. One is for age, another is for gender, another is for ethnicity. For each of the branch, we have some default set of uh, layers. And then we have uh, feature specific layers. So there are two stages. So first, we have defined default hidden layers. So each of these hidden layer has conv 2D layer, then the activation layer. We do the batch normalization, then we do the max pooling, then we do the dropout. Dropout makes sure that I am not running into overfitting issue. So then I have created different specific branches, feature specific branches for ethnicity. So I call the default layers first, and then I go through a set of layers here. I have used a softmax activation function because it's a classification problem for the ethnicity. For gender, I have used sigmoid because it's also a classification, but there are only two groups, 0 and 1. So that's why I have used the sigmoid. And then for age, it's a continuous variable, so it's not it's a regression problem. So I've used linear activation function just to uh, do a linear regression model. So finally, I combined all three branches into a single model. Then I compile the model using defining different loss functions. Like for age output, I have used mean square error because it's a continuous regression. It's a regression problem. Then I have ethnicity categorical cross entropy. For gender, I have used binary cross entropy. And you can see here that I've used different weights for different losses. Like for age output, I've used 4, ethnicity, I've used 1.5, gender 0.1. This is kind of, I'm going towards a multivariate loss functions that makes sure that the intercorrelation between age, ethnicity, and gender, the prediction correlation, those relative effects are properly balanced. So finally, I looked into these matrices uh, for the model. The model is printed here. You can see clearly I start with the input layer, the images, input images, and then I go through the default layers, and finally I reach out to the output layer for different features, age, ethnicity, and gender. So this is the summary of the model. And then I think you will be, I think you will see a lot of errors. I mean, you see a lot of error analysis and accuracy analysis that I derived from this model in the later part of this presentation. Thank you.
Hi, this is Vasim. So I'm going to talk about Model 2 implementation for our project, and then conclusion based on two model implementations. So let's check the notebook or code implementation for model 2. So basically, the pre-processing of the data and reading the input data distribution, that's pretty much same what we have seen in the model 1. So basically reading the data from the Google Drive and describing the data, checking some of the records, and then checking if there are any null records. So there are no null records in our data sheet. So, and then plotting the distribution here. So this is an age distribution which we can see. So we have lot of records with the age between 20 to 40 as compared to between 60 to 100 and 0 to 20. So I mean it is going to be a little bit biased data. And then race distribution. So we have total 5 race, and this is the distribution. For 0 it is high compared to other races. And then gender distribution. So gender distribution is pretty much same. Based on this plot we can see. So now let's talk about how we have implemented this model too, right? So I mean basically just printing out the sample images to check the reading of the data is successful. And now from here, we are pre-processing this data. So basically, as we have to predict 3 different things, right? Age, gender, and ethnicity. So we are collecting all these variables into one list, one label list, and appending it into the one list so that we can have our y variables, and definitely the x variable is our image. So I'm just printing X train and Y train. After splitting the data, we're splitting it into 70-30 for this particular model. And you can see the Y train data details. So you can see age, gender, and ethnicity basically coming into one list. And then checking the train and test shape, so which looks good. And then from here, I'm just collecting these Y variables in a particular sequence and then passing on to the model. So now let's talk about the our CNN model. So as explained in the introduction, why we are using CNN is basically it is good for image processing, and it has higher accuracy over other models when it comes to image processing. So building CNN. So as you can see, different layers here: convolution layer, an activation layer, dropout layer. So what we have done here is we have kept these layers common and generating multiple outputs from the same model. So in the model 1 we have individual layers, so the implementation is different. So in this model 2 the implementation is different, where we are using common layers, and then at the final step we are splitting out and generating 3 different outputs. So for gender, we have used the softmax activation, as we have categorical split here. For age, we have used linear activation because we are not categorizing the age, where it is kind of a regression thing, linear regression. And then for ethnicity or race, we are using the sigmoid function, which works best for the categorical outputs. So this is how it is, and we are generating 3 different outputs. Then training the model on this particular image shape 48481. This is the model summary which you can see. So with this model we are getting 118, more than 118k of parameters, in which 416 are non-trainable. So, and then this piece of code is to just check patients and call back if the model is not reducing the loss, then it will stop execution. So basically we are running this for 500 epochs. So, and then this is the pictorial view of the model layers. So input layer, first convolution layer, then activation, batch normalization, max pooling. Then it repeats for 3 times, 4 times, and then we are splitting it into multiple outputs distribution. So model evaluation, when we are testing it, and based on results we have observed in this particular model, the value or the validation loss is very high, and so we have tried to change activation functions. We have tried to change the layers, modify the batch size and everything, but still the validation loss is very high compared to model 1. And these are the, and we can see here the model loss, overall model loss, which is in hundreds. And then, but when we look at the accuracy, so for gender, it is pretty much above 60%. Age, mean squared error, as it is a linear, so instead of predicting the accuracy, we are going with mean squared error, which is approximate 10%, which is again higher than the model 1 implementation. And ethnicity accuracy prediction is close to 45 to 50%, which is again less than model 1 implementation. And this is just a linear regression plot for actual age versus predicted age. And now let's look at some of the predictions. So we have defined one function where you can just pass the index from the data set, or even we can upload image which is outside of the data set. But for now, we're just using the image from the current data set. So the function is defined to pass the image index, and it will use the model which we have created. So based on that, you can see, still there is some loss in age prediction. Gender prediction is pretty much good, but in ethnicity still there is some more loss, or we can say the model is not behaving correctly. So these are some predictions for this particular image. It is working perfectly fine. So definitely there is some loss in age, but gender and ethnicity prediction is exact. So that's how this model 2 is working. So now let's talk about conclusion. So in the report we have documented and compared both the models. So in conclusion, the model 1 prediction accuracy is higher than model 2, and we can see that in the precision here for the model 1. So, and even for gender prediction. So in conclusion, the model 1 is working better than model 2, and that's all from this model 2 and conclusion part. Thank you.